Okay, let's do this. Last class we went over tons and tons of vocabulary associated with circles. This was like our foundation. Okay, so make sure you take a look at your notes and review all those. The new stuff in this section has to do with this diagram. And so notice this is a tangent line, and this point right here is what we call the point of tangency. And it always turns out whenever you draw a radius to the point of tangency, you are always going to create a 90-degree angle. Now I just said radius, but if I draw a radius or a diameter, it's going to produce the same thing. That's a fact about all radii in diameter. When you draw it to the point of tangency, you're going to create that 90-degree angle. So if I just sketch in another tangent line in here, and I make that the point of tangency, you can see if I draw in this radius, then this is guaranteed to be perpendicular. All right, that's the first part of the new stuff from this section. The second part, we briefly taught this last time, is notice we have intersecting tangent lines. We have one tangent line out here and a different one out here. And when intersecting tangent lines intersect, the distances they produce from that point of intersection to the points of tangency, those two segments are going to be equal. Notice I'm not saying the blue one is equal to the yellow one. I'm saying the two intersecting tangent lines that go all the way to the point of tangency, those two are going to be the same. And I'll use a different color in here. This is the intersecting tangent line along with this one. They intersect, so therefore those two little bitty segments are congruent. So pretty easy to kind of comprehend what's going on here with our color, but a little more difficult to apply as we do our pictures. Let's take a look at the first example. So again, to recap, we have tangent lines and radii, they're going to be perpendicular, and then we have intersecting tangent lines, they are going to be congruent, those little tiny segments. All right, let's take a look at this problem. So when I take a look at this problem, I bet most people just see a triangle and a circle, but what you really need to see is this is a tangent line. So if that's the point of tangency, we have a perpendicular angle right there, perpendicular lines producing a right angle. Therefore, we can now find x. Now you have to go back to chapter 9 and see that we can use sine, cosine, or tangent, some trigonometry, if needed, to find some of these sides, or in this case, we just have to find the angle. We're not going to use any trig, but in other problems, we'll be using trig. In this case, I know two angles in this triangle. I know 90 and 58, so if I use the angle sum theorem, 90 and 58 is 148, and if I subtract it from 180, I get 32 degrees. So x turns out to be 32 here. All right, let's try another problem. Number 2 here is I see a circle and two intersecting tangent lines. So my brain sees these two segments are going to be equal, and I also see a radius and another radius. Therefore, we are producing what? 90-degree angles. So now my brain sees a quadrilateral, and what do we know about quadrilaterals? They have 360 degrees. So if you can see that central angle is 130, and then these two other angles are 90 and 90, and so that leaves us with the mysterious angle of x. And I do know all together, all four of those angles are adding up to be 360. So if I take 360 minus 90 minus 90 minus 130, that gives us a leftover value of x having to be 50 degrees. Let's try another one. So in this picture, we have a pentagon, and these are not radii. You got to be very careful in here. These are longer than a radius because they extend beyond the length of the circle. So we want to find this angle in here. So sometimes in geometry we have to be clever enough to either draw on extra lines or see that this triangle in here with this regular, we should point out this is a regular pentagon, that these two are going to be the same in this regular pentagon. So if I take this triangle right here and I just redraw it over here, you'll notice it's isosceles. So basically what we're trying to do is find that angle x right there. And so a long time ago in regular shapes we had a formula that said n minus 2 times 180 divided by n, and that's going to give us one interior angle of a regular polygon. And so in this case this is 108 for a pentagon. That means this angle is 108, that angle is 108, this angle is 108, and so is this guy right there is 108. But if that's 108, this one's going to be 54, that one's going to be 54. Notice how I relabeled and redrew everything. So if that's 54 and 54, I take 180 minus 54 and minus 54. All together we get 72 degrees equaling x. Another connected piece of geometry that can help you find x in here is if I draw another blue line here, and another blue line here, and another blue line here, hopefully you can see that all 5 of these angles, they're all the same. And so another concept to use is, I'm making the circular motion here because in a circle we have 360 degrees. And if I had to divide it into 5 equal parts, use your calculator, 360 divided by 5, you'll notice you're going to get the same exact 72 degrees. So you can see in this example, this is a perfect example of how lots of items in geometry, theorems and concepts are all connected together, and you can tackle things in assorted techniques. Let's try one more and take a little break. So in this example, we have what? We have a circle, and what else do we see? A tangent line. And it's really important to start seeing tangent lines because radii and tangent lines produce perpendicular lines, and they also produce right angles in here. Therefore, whenever we have right angles, we can use trig, we can use Pythagoras. And so in this example, to find not an angle but these sides, I can try to use Pythagoras. I can try to go 8 squared plus x squared equals x plus 2 squared. So let me try to write that out. X squared plus 8 squared plus the quantity, notice it's the group of x plus 2 squared. So let's crank this out. Let's see if we can solve for this. X squared plus 64 equals, when we FOIL this, because remember this is another way to say x plus 2 times x plus 2, that's going to be x squared plus 4x plus 4. So when I begin to try to solve for this, how convenient, each side has an x squared. So what I can do is I can just cross them out. And so let me just try to clean up this equation here. I'm going to bring all the numbers onto one side. So that looks like 60 equals 4x, and x equals 15. And that was the goal. The goal was to find x. And we're done with this problem. All right, let's take a small break and we'll come back with a